Good morning, ladies and gentlemen. So I'm not a computing person. I'm a construction management person. I hope I'm not in the wrong session, and I'm here to seek more like technical suggestions about this issue. So I'm talking at a higher level. So I'm Jinying from University of Cambridge. I'm a Mary Skłodowska Fellow. Works on a Future Roles Fellowship program, and the topic today is building trust in carbon data to achieve net zero in the infrastructure sector, infrastructure assets life cycle. Yeah, this is my outline. And about the net zero target and the infrastructure, we all know that we have increasingly been warned on the severity of the climate crisis facing our planet. To limit the global temperature increase to below 2 degrees, we have a huge emission gap, which is by 2030 we have to reduce 12 to 33 gigatons of CO2 equivalent. But we are not doing very well in this, and the infrastructure offers a unique chance to help countries to meet their net zero targets and get back on track to meet the Sustainable Development Goals. And this report from the from the UN Office for Project Service shows that all infrastructure sectors can influence a total of 92% of all SDGs. And the infrastructure is responsible for 79% of total greenhouse gas emission worldwide. So the sheer scale of this influence on SDG and net zero targets calls for a radical change in how decisions on infrastructures are made. And now, and more than ever, that we need the decisions that are evidence-based. We need to have data on this carbon emission, and we need the data to be accurate and reliable to make the decisions. But the current situation is that we have facing this problem of trust in collected data on carbon emission, and you all know that promoting climate-friendly infrastructure requires coordinated actions from practitioners across all stages of the infrastructure life cycle, from planning and implementing to delivery, management, and decommissioning. However, the construction value chain is very long, with lots of stakeholders such as client, designer, contractors, suppliers, manufacturers, consultants, and users. So if you have played this the Shara's game, you can understand that the longer the chain, the more likely that the information would be miscommunicated, and the more likely that the fact will become a fake. So this is especially the case for carbon calculation, which requires so many specific data items, including various activity data and the emission factor data. And take the bulk material data as an example. You need to know the exact material quantities in tons or cubic meters, and the material type specifications to look up the carbon emission factors, which you also have different sources to choose. So you need to know the transportation distance of the material and what type of the vehicle is used for transportation and the fuel it used. So imagine there are so many different materials and so many activities, and we need to assess the carbon emission from in this way. It is just the current practice is more like manual reporting of what kind of material we use and the activities. And so it's hard to believe that such data can be trusted when it requires so many human efforts to get the accurate data, especially when there is a lack of strong incentives or regulations. And this example case, data flow, summarizes the problems regarding the carbon data collection and reporting based on our observations and interviews with the practical professionals in the UK. And problems relating to the data availability, data quality are the major issues, and some required data is not measured or cannot be directly sourced or hard to be collected, or like they are assessed in a not standardized way. And very often this data cannot be well shared, validated, or like protected. So the current manual data collection methods are laborious, unreliable, and not valuable for the purpose of data-informed decision-making in carbon management. And so here we propose this idea of data trustworthiness to say that defined as the degree to which data can be relied upon to be authentic, accurate, consistent, secure, and free from bias. But as shown in the use case before, we are still far from it. But still, although there are efforts to measure, verify, and manage Scope 1 and 2 emissions, there is not yet a mature and highly effective process. And moreover, the measurement and target setting and the management of Scope 3 is like currently a mess. So factors behind the carbon data trustworthiness issues include a lack of consistent and accurate data model on carbon emissions and other relevant indicators, and the lack of coordination, collaboration, and integration across all levels of the value chain, and lack of clear and consistent policies and regulations at different levels, and the lack of significant resources to support this. And yeah, of course, there is a lot of value if we can get the trustworthy carbon data so that we can do better decision making and improve the project planning for carbon reduction and saving costs at the same time. And based on all these understandings, we did some literature review and proposed this concept, carbon data trustworthiness concepts, and these key attributes, which data availability, quality, compatibility, and security are the 4 key pillars of the carbon data trustworthiness. And this guidance framework to how can we achieve like enhance the data availability and quality and compatibility and the security. We need standardized data structure and clear stakeholder responsibility and streamlined data collection procedures, automated data collection methods, and like trackable data flow, and trackable and shareable data storage, as well as some common data environment, standardized data protocols, and open data formats for data compatibility, which I think in this event you will talk a lot about it. And also the data security is a big issue because carbon is associated with a lot of maybe commercial, confidential information. So how to secure, make stakeholders to share the data in a secured way. We mainly distribute data storage and role-based data report and access and sharing and analysis rights, and also the data encryption, something related to that. And so this is a conceptual system, digitalized carbon management system framework we proposed. We aim to develop some, the key thing is the carbon metadata structure. We want to have the, based on the current carbon reporting practices and the availability of digital technologies to develop a carbon metadata structure so that we can standardize data requirements. And based on this, we can just, maybe we can firstly start from grabbing some data from the existing models or databases like the BIM models or like the bill of quantities and some site logs and the other like ERP and IoT databases to get the data there and try to format, like try to transfer them in the same format so that we can have a carbon, like a centralized carbon management system database for other extra or like more advanced data analytics and decision-making applications. And I think I'm most finished, and we identified some key factors like standardized data model, reliable data sources, automatic data collection methods, and all about these data things, like more from a data architecture level. So if you're interested in this, like when you do your computing in the construction, if there is something related to carbon or like its measurement, reporting, I would like to talk about that. And this project has received funding from the EU's Horizon 2020 research project, and also a lot of the support from our road research aligns with all these companies. And this built trust from the level of data in carbon sense. Thank you.